Hi everyone, this is my Create Your Own Adventure where I will be modeling the solar system. My objective was to computationally model the solar system so that all of the planets were rotating around the sun. I did this by using planet information that was given to me. I then wanted to accurately predict the length of a year on each planet other than Pluto. The reason I did not find the length of a year for Pluto is due to the fact that it took nearly 2 hours for it to run completely and then my computer froze. My main results were that I was quite accurately able to predict the length of a year for the planets. There was a bit of a discrepancy for some, but all of them were pretty accurate. In this lab, I use Newton's law of universal gravitation so that we can find the F-net acting on the planet. Again, Newton's law of universal gravitation is found by taking the constant g, which is negative 6.67 times 10 to the negative 11th, and multiplying that by the mass of the planet times the mass of the sun, and then dividing it by the distance squared between the two objects. I also use the momentum principle in the lab. I use the first equation to find the initial momentum of each planet. Then later, once I was able to find the F-net, I used the second equation to find the final momentum, which then helped to find the updated position. Here is the planet information that was given to me that I could use. It was here where I found a lot of the information that I would use in my code. To start out the code, I had to initialize everything. In this part of the code, you are able to see where I made a sphere for each planet so that when I ran the computer model, they would all show up. I left the radius of each planet and the sun the same size so that they would show up when the code was run. The radius was not needed for any other calculation, therefore I left them the same. The next section is where I initialized the position of each planet. The number that I used there was from the planet information that was given to me. This was the mean distance from the sun, and I started them out all on the positive x-axis with y being 0. The last part of the code is where I stated the velocity of each planet. This was also given to us in the planet information and was the orbital speed. Of course, I had to change it into meters per second. The next part of the code is where I put in the mass of each planet, which was given to me. And then the momentum principle comes into play here. Here I found the momentum of each planet by taking the planet's mass and multiplying it by the planet's velocity. I then defined the g constant, which is used to find our F-net of each planet using Newton's law of universal gravitation. I also have a delta t of 86,400, which is equal to 1 day in seconds. I then turned to the while loop where I changed the time for each planet so that I could get the planet to do one full rotation around the sun. I then find the distance between each planet and the sun, which I then used to find F-net. I found F-net for each planet by calculating Newton's law of universal gravitation as discussed earlier in the presentation. I then used the new F-net that was calculated to find the new momentum of each planet. From there, I used the new momentum to find the new position of the planet. I have included the equation that I used to find the new position. We used momentum due to the fact that we found F-net and to make sure that the new position would be in a vector form. Here's a representation of what the computer model looks like after running a bit of my code. As you can see, some of the planets are orbiting around the sun more than others since their velocities are faster. Here you're able to see a picture of how Earth has made one complete orbit around the sun, and the Earth is the blue one. I included code so that there would be a trail behind the planet. The graph on here is something I created so that I could see when each planet made a full orbit. A full orbit is when the line goes from negative to positive in the y direction. In the code, I also asked for it to print out the time and y positions of each planet so that I would be able to get the best guess of how long the orbit was in seconds. Here you're able to see the length of a year for each planet. Other than Pluto, my computational model and the actual length of a year for each, the actual length of an orbit for each planet is shown. I switched it back into days instead of leaving it in seconds, which is what was outputted for my model. Based on this, I would say that my computational model predicted the length of a year by an Earth year, quite accurately. However, there are some discrepancies. I believe that here there are discrepancies due to the fact that I modeled each orbit to be completely circular when in reality the orbits are elliptical. This could have been the reason why I got the differences that I did. Hope you enjoyed the lab. Thank you.